Hey, everybody. I'm Carl Moberg. I'm the CTO of Avassa. And this is a session where I will demo our Avassa platform. I will do this solely using a web UI. I think that is probably what is the easiest to consume during a setup like this. I will tell you that there's going to be YAML for the YAML geeks as well, but most of the time will be spent in a web UI construct. And this demo is actually based upon a made-up scenario. And we have worked quite a bit to try to find out what's a good scenario that both makes sense and is also instructive. And we've figured out that everybody knows what a movie theater is. And since this is an edge cloud computing demo, we will assume the role of owners of a movie theater chain. So we will have movie theaters, actually 100 of them, spread across the globe. And I will show you in a little bit of a brief fashion here what it looks like for a movie theater owner to set up and deploy a popcorn management software to a certain subset of the movie theater locations. So the first thing I do here is that I log into our system. And since this is a distributed edge cloud environment, of course, there's a map to it. And this map, of course, I can zoom in and zoom out, and you'll see little blue dots or blue drops on all the locations that we have deployed in this system. And each of these little blue markers here represents what we call a site. A site is obviously a location, but it also has a set of hosts. So maybe one, maybe three, maybe five, a couple of them. And so I guess the first data structure that's important in this system, the first kind of list here is, of course, the number of sites. So this is also a list of sites, and we'll take a look at my home site here because I'm based out of Stockholm, Sweden. So we'll filter that out and we will zoom into it. And of course, it's a map, so we can fly into this location here. And it's downtown Stockholm, just nearby where I am. And because this is a short demo, all the sites that I showed you have already called home, right? So they've already associated themselves with this control tower instance, and they have reported what they know about themselves and about the world. And some of that is actually available here in the state pane. So we can see here that this is a single host site. So the ID of this host is here, and it has reported that it's a x86-64 platform and some data around what kind of chassis type and kind of vendor version, product name, all that kind of stuff it has. This is part of the call home process. So after this, of course, the control tower understands what kind of resources this system has to offer to people using it. We also have a set of labels here. This one is of system type edge, meaning that this is actually a site that you can deploy to. It's in the Europe region and it's in Sweden. And as I mentioned before, this system obviously has a couple of interfaces. So it has a command line interface, it has a web UI, and it has a REST interface. So for people that are more towards the infrastructure as code, you can always hit YAML and you will see the exact same data, but rendered as YAML. And there's also configuration here. So as the owner and the manager of this system, I can, of course, add new labels here. I can pre-configure new hosts. I can give this all kinds of names. This is kind of the basic data that we need to manage each of these sites here. So what we want to do is start talking about how to deploy things. How do we actually deploy applications on this system? Now that we know that we have the concept of sites, we can talk about the next set of data sets here. So the next concept here is what we call an application. An application is basically a way to explain to this system what an application looks like, what an application topology looks like. And we do that in terms of containers and their relationship to each other and what kind of resources they need from the surrounding environment. I'm going to register a new application here. And again, this is for the programmability people. This is the way to express to this system that at its most basic, We can have an application with a name. Again, this is a popcorn controller, so this will manage the popcorn machines. We have versions on the applications. Each application can consist of several services. And you can think of services as the schedulable or deployable set of containers. In this case, we have a super simple setup. It's a single container. And this container is actually hosted on our public GitLab based container registry, so it's readily available. We don't have to do anything particular about this. We will have to tell the system how to manage this if the site it ends up on is a cluster. So in this case, we'll say, please try to keep one replica of this application alive at all points in time. And what this is to the system is actually configuration. So when I submit this, nothing much happens. It's basically a way of saying that you should get ready with this kind of configuration for a service when it starts matching something. So I can make sure always, of course, that the container was available. So we can see now, yeah, that container is present. So we pulled it off of the external repo, or sorry, the external registry. Of course, many of our users use EKR or other types of either private or public registries. So this container is now pulled into our local registry and is ready for deployment. And the other half of this equation here is what we call a deployment specification. So a deployment specification is a means for me to tell the system, again, under which circumstances do we deploy this application. So in this case, again, I'm keeping this super simple. I, as the owner of this movie theater chain, will tell the system that I want to deploy the application Popcorn Controller of version 1 in Sweden, Norway, and Finland. Okay, so those are the matching criteria for the sites that I want this application to run on. And when I hit submit here, when I configure the control tower for this, of course, it's going to recognize that we now have an application that matches a deployment specification, and it's now up to the control tower to make sure that this starts working towards an end state of having those applications running on those sites. So I will submit this. And we'll go back to the deployment, and we'll see that it matched a number of locations here. And you have to trust me that these are the sites that are in Sweden, Norway, or Finland. And we can always look at the state, and it's deploying still, but it has the image present. So we'll go back and make sure that it's actually deployed. So at this point, this is actually now deployed. So the images are distributed to the local registry in the sites, and it's actually been started. So we now have the Popcorn Controller application running across Sweden, Norway, and Finland. Now, that's not all there is to it, right? That's just the beginning. Of course, now starts the really interesting part of these things, which is life cycling all these things over time. And a very common thing, of course, or two common things we can do here is to ensure that we're running the latest version of an application, and we're running it in the appropriate places. So I just got word that there's a new version of the Kettle Popper Manager software, and that I'm being also asked to deploy this to all of Scandinavia. And for those who didn't pick that up, we're missing Denmark to be fully Scandinavian here. So I've been asked to upgrade the container version, and I've been asked to add Denmark. And as you've maybe figured out, that's a matter of going back to the configuration of the deployment. Or actually, let's do the application first. First, we go to the configuration of the application, and probably not a surprise, we will upgrade the tag for the image. We will submit that, and then move on to the deployment. Edit this, and we'll just add or Denmark here. So by actually updating the configuration of the deployment specification, the system will now again start to converge towards the combined configuration of the application and the deployment specification. So we'll submit that. Make sure the application looks fine. We will go to the deployment again, and we will make sure that, yeah, that it's deployed across all the northern countries here, or sorry, the Scandinavian countries, and that version 2.0 is deployed. So by doing that pretty simple operation here, and again, I'm doing it point-to-clicky, obviously that could also be an update to an infrastructure as code set of manifests you would have under version control. And of course, you can do this arbitrarily complicated. We could have removed things, or we could have added other things, or maybe upgraded parts of the solution. So it's a matter of explaining to the system what to do, and then, of course, allowing the system to converge to the correct end state. And the way we remove the applications is by simply removing the deployment. And this will literally take down or bring down or allow all the sites that actually has this service deployed to destroy the containers and clean up the local cache or the local copy of the container in the distributed sites. And if we don't need the application anymore, we'll do the same thing here. We'll simply delete the application definition. There we go. So I showed you the basic definition of what a site looks like and what the system sees from a site, how to define an application, which again is a small topology. I showed you the bare minimum, which is a single container application. How to connect that to the criteria. In this case, I used some label matching for countries to deploy an application across about 20 locations. I showed you how to change the configuration, both of the application and the deployment specification in one shot, and allow the system to converge to a new state. And then how to remove the containers or the applications from the constituent sites in a single operation. So this hopefully is a reflection of the abstractions that we think are appropriate for easily and securely managing applications across a distributed set of, in this case, container runtimes in a way that, again, is easy to consume both for humans, but as you can imagine, also easy to integrate with the tooling you may have in AWS, GCP, or Azure, or for that matter, in on-prem solutions like a Terraform or an Ansible. And we think this is a minimum and normalized way of doing it that will serve the value or the needs of the application teams, and don't go too much overboard on the infrastructure side of things here. And I'll just briefly show you that there's this tenant concept that I talked about previously that allows an edge cloud manager, like the role that I'm logged into now, that has full control over the infrastructure, to assign to application owners. In this case, we've invited a new vendor called Popcorn Systems that will eventually take over the development and management of the Popcorn Kettle Manager application. And we can see here that as an application owner, they have a set of sites assigned to them. So in this case, I've assigned only the Swedish sites because we want to trial them. We want to try them out only on the Swedish sites. So if they were to log in, of course, they would see a little less than I do as the kind of root user here, or as the Edge Cloud Manager, and they will only be allowed to deploy to the sites that I've assigned to them. So we'll keep them inside of Sweden for now before we allow them to go further than that. Just wanted to show you the concept of an application tenant here. That kind of wraps up this Blitz style demo. Hopefully that made sense and kind of further gave color to what I'm talking about here, and more than happy and excited to take any questions.
Hi, Carl. I'm Athar Beg. I work as an enterprise solutions architect and specialize in multi-cloud infrastructure. Great demo. And first of all, I'm glad that if I go to the cinemas that you mentioned, I'm not going to run out of popcorn, thanks to Avassa systems. Just want to ask a couple of questions regarding this demo. So first of all, when you were making changes, for example, you initially deployed and the application, but then later on you made changes, not only upgrading the version, but also adding another site, for example. How are there any controls in there in the interface, which then allows you to determine when the convergence starts happening as you're making changes? Because sometimes you want to make all those changes and then let it start converging rather than it happening or starting partway.
Oof. That's a big one. So partially, yes. one of the things that we found super interesting is the conversation of talking, for example, with application operations teams and having them play around with, and maybe trial the system. They recognize that with a click of a button, be that in a web UI or for that matter, a code deploy hook or something like that, they may fire up applications in hundreds of places. It's not a super comfortable feeling. It turns out when you're used to working with maybe 1 or 2 copies of your application, and you normally have 2 just for disaster recovery, like firing up 1,000 is cognitively challenging. So one of the things, before I kind of get to what I think you're asking, or what I believe you're asking, is there are ways to pace the deployment of the applications themselves, right? Back when I used to work with email system, we had something called thundering herd, which is to say, try to get rid of all email in your spool at the same time, which usually led to very sad receivers. And so, of course, if you want, there's a basic, and maybe if your edge cloud is limited in size, you can configure the system to just do thundering herd, and we'll do parallel deployments, right? But there's also ways of pacing yourselves, and you can even have what we call canaries, right? So do a couple, make sure that the actual container level health checks pass, and then do more. Usually, paced in bigger and bigger groups. There are other ways as well to do that with wait times and all kinds of things. So I want to say that is actually what we worked pretty hard on, to make sure that we have a flexible policy system for that. I will say to your direct question is that there's currently no way in this system to say, I want you to do this, but not when I click submit. So today, there's actually no way to do that. So you actually have to pace that last submit here to a time when it's appropriate. But of course, that suffers from the fact that I'm in front of the web UI, right? If you actually have an automation system on top of, if you like, or integrated with the system, you can, of course, make sure that system does it at the appropriate time. But Arthur, I will take it as a feature request, being the product manager here, to see if wall clock time should be a configurable parameter here. But it is a very, very interesting topic. The whole, almost, the whole experience of deploying to vast swaths of locations through simple means like this actually has it's a little bit of a double take moment for many of the conversations we're having. People do a double take when you hit submit here, we'll deploy 3 containers to 1,024 places. Are you ready? Click, right? And they're happy to see it, but in a real operational environment, that might not be the best way to go about it.
Yeah, thank you. I mean, that's exactly where I was going, because I mean, I could see that happening in absence of some bells and whistles, controls without having them. Yeah. A related question, actually, I was going to ask also was that, and probably is related to this thing as well, that, or maybe a future request, maybe, is there a what if feature, for example? Again, as you were changing configuration, as you added a site, for example, it did show that, the deployment will happen on these sites, but at that point it was also deploying. So is there a trial? So this is where I'm going to deploy.
Yes.
And not actually deploy it.
Right. So you're gravitating towards my favorite conversations here. I will say this. We have basic means to do that because it turns out to be more challenging than perhaps at a cursory glance. Remember, we have that matching pattern in the deployment specification. Things change over time, which means, for example, that if you do what I would call, based on my background, a dry run, that the second after you've inspected that dry run, which it usually means, things may have changed sufficiently enough that another dry run will be different. Particularly when you start matching on things that are based on less static data. You could almost think of, maybe this is a useful way of thinking about it. The sites themselves expose data to the control tower in, let's say, a tree format. In that tree, you have things that are very static. For example, the serial number of the motherboard. You have things that are somewhat static, things like which Ethernet interface is available. And then you have things that are way less static. The worst case, of course, is temperature, but don't use temperature to match, right? So things that are out of the control of anyone, right? And between the control tower and the edge enforcer, there's literally if you like, a state machine that does the matching, right? So make sure that when we ask, we match on the right things. So it is trivial to do merge or if you like, deltas or diffs based on very static things. I could have shown you in this demo, of course, the delta without actually firing off the deployment based on that kind of static data, in this case, labels that only change if I change them. But we're a little careful here on how to design this for less static data. Things like CPU load, for example, things like available RAM, which may actually change really, really rapidly. So it's a partial yes to your question. And I would love to come back with you in more detail as we start to figure out how to do useful and understandable matching on things that change over time. Because I love your intuition. It is, again, terrifying to do without actually being able to see this before you fired off. And you could also think of down that path a means of playing around with the label space and the matching pattern, and to make sure that it actually results in what you want instead of trusting that you got it right. So good point.
So Carl, here's Max Mortillaro. I'm a co-owner of Tech Unplugged and analyst at Gigom. I do have a question on your solution scalability, because what we've seen looks pretty awesome, but how does that scale? So I'm thinking here think about, for example, a hypothetical fast food company which has tens of thousands of locations across the globe. Think of, companies, airports, whatever, all over the place. How does it works at the, let's say, architectural level? Because if you have to push something, as you showed in the demo, to 100 places, maybe that scales well. But if you have to do that globally, then if we even think beyond what Ater just said around, pushing and staggering the distributions, is the architecture able to sustain that elevated amount of communication? Or if that's something you're planning for the next releases of the product?
I will take the cheap answer first, and I'll say, yes, the architecture is fantastic. It will scale awesome. The implementation, however, is, of course, something we're working on, right? And you are right. I mean, I probably didn't stress this enough, is that multi-tenancy and scalability really, really guides many architectural decisions if you were to build a system like this. It's something you have to really, it's what's pushed us to do specific implementations of some of these basic features here, because we knew that borrowing others or using others' implementations won't scale. And also, I will add to that based on our previous lives, we know we had a saying in some other softwares that we built: every order of magnitude brings unknown challenges. And so I can say this much. First of all, this demo is actually running on 100 sites. They're not physically distributed across the map, but it's 100 sites. Anyway, so yeah, so as you can see, so we're easily demoing this on 100, and hopefully you can take it at face value to say that hundreds are okay. Above that, it becomes a little more challenging to simulate. Again, based on previous experiences, we know the difference between, let's call it stubbed out edge enforcers or stubbed out sites and how they behave, and actually distributing containers and running them and collecting logs and all that kind of things. So we're working on that. So I'll say that for now, we can easily manage hundreds. We are working on proof points for thousands, and we believe the architecture will take us above that, plus, of course, the experience of actually doing it. So, of course, the target we have is hundreds of thousands, and we have had some very forward thinking customers, for example, in the cable space, that are considering putting container runtimes in set-top boxes, which means that you will reach staggering amounts of container runtimes. And of course, we believe that our architecture, eventually the implementation will be able to take us there.
Yeah, so one thing to add to that, I mean, what triggered my question was some recent experience with some fast food over the place, and the fact that regardless of where you are in the globe, the experience seemed to be pretty much consistent. So there is an implication of a common framework, common application architecture to deliver the service. However, there are some localizations, and that could lead to some, let's say, a kind of a distributed architecture where you would have, for example, a controller, a control tower in each country, for example. The thing maybe what's going next is maybe having a kind of a management layer on top of the access tower where you can manage all of the other distributions. I've seen that in some other software implementations. Might be a hint.
So actually we call that autonomy zones, and that is actually available in the system, but I didn't want to heap too much complexity on this kind of first demo and first presentation. So you can actually build a federated system of control towers, and that actually comes out of some of our early users where they need autonomy also on the control plane, for example, across nation borders or across parts of a nation. So that's actually in there in a sense, which means that you will have a central or a central control tower. But then if you lose connectivity between the distributed or in between control towers, they will actually function for the subset of edge sites that they control. That also, without giving away too much, kind of explodes the complexity of some of the aspects of building a system like this. And something we're quite excited about, but it's something that's a little hard to cover in a demo setting. But I'm more than happy to come back and show you what that looks like in more detail.
Carl, this is Mike Stump, a consulting engineer and analyst. I do have a quick question about, I guess, the other side of the what if scenario, which I think is really interesting. So let's say that without any ability to gauge what's going to happen when you click deploy, let's say that something gets deployed and it does not go as planned. What methods do you have? And I think I know the answer, but I just want to hear it. What methods would you have to quickly roll that back? And related, do you have a method for logging events or for having some type of auditing system in place so you can say, why did Mike Stump do this at 1:23?
Awesome. So for the first question, let's call it like mid-flight hesitation or mid-flight need to roll back. What you actually do is what I did to clean up the system. You simply remove the explicit specification or the deployment specification. That will trigger the control tower to stop what it's doing in order to, in terms of what's left pushing towards the edge enforcers, and also bringing up with the edge enforcers that already have the applications maybe even started to remove them. So you could, I know it's a easily bandied about term, but you think of this as an eventually consistent system, and that means that you will while something is working towards consistency, you change the target configuration. It gets more complicated though, because of course you may have non-responsive sites, and it seems to be an opinionated decision on what to do about that. So let's say you have 64 sites and actually 10 of them are down, but that's something you recognize only after you've decided which sites to deploy on. While trying to do that, there's a whole discussion about whether that should actually stop the deployment, right? Does that mean that the deployment is failed? Or for that matter, even perhaps more complicated, you're deploying to 1,024 locations, and to your inexplicable horror, you realize that as my applications start coming up, they immediately start crashing or failing. Does that mean that I immediately stop the deployment of the other 1,020, or do I allow them to proceed and then try to figure out what's wrong? So there's a pretty interesting and granular interaction between the intent of any operation here and the mid-flight result and the eventual result of the applications themselves. And some of these things are very straightforward, somewhat straightforward, which is to say, just removing or changing the intent will actually reverse the process or stop the process and reverse what's already been done. To more complicated things like a high watermark for failure, right? After which you will stop the deployment and roll back, which are more, well, based on our own experience from other types of systems, is probably going to be more of a conversation or configuration, because the opinions are strong and varied on what this is. And if you add to that, is that there are a somewhat limited body of experience with running applications in thousands of places, replicas of applications in thousands of places. It can be hard to even form a strong opinion at this point, which means that as a vendor, of course, that needs to be somewhat configured, maybe.
And I could even see the risk of exposing that type of configuration option to an end user, because it would be easy to configure a problem for yourself as you misunderstand how the deployment is supposed to go. So I agree that it's a hard conversation to have, and I don't know what a customer would eventually want to do. Maybe they would just accept that sometimes the application won't work.
Yeah, and you know what? I think, again, what's cool about it is that we have structured data to work on, right? So you could easily think of an internal policy language in the control tower, for that matter, external policy decision points to say, if you're this kind of user, you're not actually allowed to deploy to more than 5 sites at a time, right? Or at this point in time, if more than this number of failed applications come up, then roll back, because we have much fewer people available to work on this, right? So the cool thing about it is that this data is all available through the APIs, right? It's exposed. So coming up with ways of structuring policy on top of it will be a very exciting kind of next step here with our user base.
Got it. Thank you.
Thank you very much, guys, for your questions and some of your feedback. Duly noted some of the feature requests here. Hope this was further enlightening and that it made sense. I'm always excited to show this to people. So I hope you got something out of it. So thank you very much.